A network stretching 50,000 kilometers is enough high-speed rail to wrap around the equator. To coordinate thousands of trains moving at 350 kilometers an hour, carrying billions of passengers every year across vastly different terrains and climates, requires more than just human oversight. To the naked eye, it looks like an engineering miracle. But if you tried to run this system with just human dispatchers and paper schedules, it wouldn't be a miracle. It would be a disaster. The truth is, China's high-speed rail network isn't just steel and concrete. It's a massive, sprawling digital organism. And today, we're logging into its brain to see how artificial intelligence is running the biggest transport show on Earth. Let's go. When the network expands as fast as China's has, traditional management breaks down. You can't just add more people to manage more trains. You need exponential intelligence. The China State Railway Group has been heavily investing in what they call a superbrain. This isn't one single AI, but an integrated ecosystem of machine learning algorithms, computer vision, and predictive modeling that touches every single part of the journey. Let's start with the hardest job: scheduling. In the past, creating a train timetable was a static process done months in advance. But China's network is too volatile for static schedules. A sudden snowstorm in Harbin, a power spike in Shanghai, or a massive surge of travelers during Chinese New Year. Any of these can create a butterfly effect that ripples across the whole country. This is where AI logistics shine. The system uses historical data and real-time inputs to dynamically adjust schedules. It doesn't just react to delays, it predicts them. If a train is running 2 minutes late into Beijing, the AI instantly recalculates the ripple effect on the next 50 connecting trains, adjusting their speeds and platform assignments automatically to absorb the delay before passengers even notice. It's playing 4D chess with thousands of pieces, 24/7. But the AI doesn't stop at the tracks. It's running the stations too. If you've ever traveled high-speed rail in China, you know the stations are enormous, sometimes bigger than airports. Managing the crowd flow here is critical for safety and speed. These stations are covered in smart cameras feeding into computer vision algorithms. The AI analyzes crowd density in real time. If too many people are gathering near escalator B, the system senses a bottleneck forming. It can automatically redirect passenger flow by changing digital signage, opening extra security lanes, or alerting station staff to manage the choke point before it becomes a safety hazard. And, of course, ticketing. The move to ticketless travel is powered by AI facial recognition that verifies identity against the national database in milliseconds, processing thousands of passengers per hour per gate. We know AI runs the trains, but it also helps build them. The latest generations of trains, like the CR450 project aiming for 450 kilometers per hour speeds, are born inside a computer. Chinese engineers are heavily utilizing digital twin technology. Before a single piece of metal is cut, a complete AI-powered virtual replica of the train is created. They run these digital twins through millions of simulated scenarios: extreme heat, Gobi Desert sandstorms, typhoons. The AI analyzes aerodynamic drag and noise levels, iterating design changes thousands of times faster than physical prototyping ever could. This is how they are pushing the envelope on speed while reducing energy consumption. But my favorite application of AI is the maintenance. How do you inspect 50,000 kilometers of track and thousands of train cars every night? You don't use humans, you use robots. When a high-speed train finishes its day, it enters a maintenance shed that looks like a sci-fi movie set. Instead of a team of mechanics with flashlights, AI-powered robots slide underneath the train. They use high-definition cameras and sensors to take thousands of photos of bolts, wires, and wheels in minutes. Computer vision algorithms scan these images, looking for microscopic hairline cracks or anomalies that a human eye would miss. And for the tracks themselves, They have the yellow doctors, specialized high-speed inspection trains packed with sensors. They drive at full speed, using lasers and AI to scan the rails for deformations, measuring in the millimeters, predicting track failures before they happen. It's shifted the entire system from reactive maintenance, fixing what's broken, to predictive maintenance, fixing things before they break. What China is building isn't just a faster way to get from city A to city B. It's a blueprint for the future of infrastructure. It's a system where the hardware, the steel and the trains, is inseparable from the software that runs it. The next phase? Fully autonomous high-speed train operation, which is already being tested. The driver will become a system monitor, while the AI handles the throttle and braking with superhuman precision, saving even more energy. The scale of China's rail network demanded artificial intelligence, and now that artificial intelligence is redefining what's possible in transportation. What do you think is the most impressive part of this AI network? The scheduling brain or the maintenance robots? Let me know in the comments down below. If you enjoyed this deep dive into transport tech, smash that like button and subscribe for more stories about how the future is being built today. Thanks for watching.